Today we're going to look at Sanskrit a little differently. Not just as some ancient language, but what if it's a science? Like an actual architect's blueprint for sound itself.
And that really begs the question, right? Is language just a jumble of words and grammar rules we all agree on? Or can it be something more, something engineered? Well, we're about to find out by looking deep inside the very structure of Sanskrit.
So here's how we're going to break it down. First, the basic blueprint for sound. Then we'll look at vowels versus consonants. After that, we'll uncover the alphabet's master plan. Then we'll get into the real nitty-gritty, the engineering of a sound. And finally, we'll see how this whole thing comes together as a system of pure precision.
All right, let's jump right in. Section 1, the blueprint for sound. You know, if you want to understand any big, complex structure, you've got to start small. I'm talking about its most basic parts, its atoms. And in Sanskrit, that atom is called a varna. Now, this isn't just a letter you write down. No. It's the pure, fundamental sound itself, the smallest possible sound we can make with our mouths. It's kind of like the elemental particle of speech.
Okay, so we have these sound atoms, these varnas, but they're not all created equal. They basically fall into two main buckets, and you can think of them as the two main materials an architect has to work with: vowels and consonants.
What's really cool is how Sanskrit itself defines them. A vowel, or a swara, literally means that which sounds by itself. It's totally independent. You can just say ah or o, no problem. But a consonant, a vyanjana, that means that which follows or is supported. It needs a vowel to even be heard properly.
So you might be wondering, how do you get just the pure consonant sound? Well, Sanskrit has this really clever little tool called a halanta. See that tiny little slash under the letter? It's basically a mute button for the vowel. It strips away the built-in ah sound that comes with every consonant, leaving you with just the raw sound, like the pure k in k.
So how big is this toolkit of consonants? Well, there are 33 of them. 33 core sounds that are just waiting for a vowel to give them a voice. And of course, like any good toolkit, you can't just have all the tools thrown in a box. You need a master plan to organize them.
And that brings us right to our next section, the alphabet's master plan. We're about to reveal the Varnamala.
And there it is, the whole shebang, the Varnamala. Now look closely. This isn't just some random ABC list. It is a perfectly organized grid. You've got your vowels up top, and then the consonants are laid out in these beautiful rows, all grouped by how and where you make the sound in your mouth. It's literally a map of human speech.
You know, a system this elegant has to have a pretty cool origin story. And it does. The logic behind this whole chart comes from something called the Maheshwara Sutras. And the story goes that these phonetic rules weren't invented. They were revealed through the sound of Lord Shiva's cosmic drum. I mean, what a perfect metaphor for a system that is all about sound and vibration, right?
So what are these sutras? Think of them as the source code for the alphabet. There are just 14 of these short, powerful formulas. And they're not just a list, they are kind of algorithm that organizes every single sound. The first 4 handle all the vowels, and the other 10 take care of all the consonants. This is the key that unlocks the whole system.
Okay, buckle up, because now we're getting into the real engineering of it all. How do you define a sound? Turns out you just need 2 key specs for every single sound on that chart. First, where in your mouth is it made? And second, how exactly is it made?
Let's tackle the first one, the where. In Sanskrit grammar, they call this sthana, which just means the place of articulation. It's a really simple question. Where is the sound coming from? Where is the action happening inside your mouth?
And this right here, this is the map they were working with. It's amazing, really. The ancient grammarians had this unbelievable understanding of our vocal anatomy. They mapped out the entire vocal tract like engineers, pinpointing every single spot: the throat, the palate, the teeth, the lips, you name it.
Okay, check this out. You can actually feel this for yourself right now. Let's start with the throat, the kanta. That's where you make the ka sounds. Go on, say it. Ka, cha, ga. You feel that? Right at the back of your throat. Now let's move to the palate, the talu. Try cha or ja. See how your tongue hits the roof of your mouth? And finally, the lips, or oshta. Say pa or ba. Your lips are doing all the work. It's not just theory, it's physically real. It's a perfect system.
Okay, so we've got the where figured out. That brings us to spec number 2, the how. This is called prayatna,
which basically means effort. Because, you see, it's not enough to know where your tongue is. You also have to know what it's doing there. What kind of effort is being made?
So prayatna is all about the specific action you take to make a sound. And this gets broken down even further into two types, internal effort and external effort. So what's the difference between what's happening inside the mouth versus outside? Let's take a look.
Okay, here's a good way to think about it. Internal effort, or abhyantara, is like everything that happens before a sound actually comes out. It's the position of your tongue, the shape of your mouth, it's the prep work. Then you have external effort, or baya. This is what happens as the sound is being made, like the amount of breath you use or whether your vocal cords are vibrating. So you have the setup, and then you have the execution.
And trust me, they get super specific with this stuff. The internal effort classification can tell the difference between the full, hard contact your tongue makes for a T sound and the super gentle, slight contact it makes for a yes sound. It's that kind of incredible detail that makes the whole system so unbelievably precise.
Let's just take one quick example of that external effort. Let's talk about breath. Some sounds are called alpaprana, which means little breath, and others are mahaprana, or big breath. Come on, try this with me. Put your hand in front of your mouth. Now say ka. Feel that? Not much air, right? Now say ka. Whoa, see that big puff of air? That's mahaprana, that's aspiration, and the system has a name and a category for it. It's amazing.
And that all leads us to our grand finale, a system of precision. We've looked at the building blocks, the master plan, and the engineering specs. So now, let's put it all together and see what we've built.
Okay, this is the moment it all clicks. Let's take just one sound, ga. Using this system, we can create a full-on technical spec sheet for it. We know it's a consonant, we know its place is the throat, we know its internal effort is contact, and we know its external properties for voicing and breath. These 5 coordinates pinpoint ga with absolute precision. No other sound in existence has this exact same signature. That is just mind-blowing.
So, we end up right back where we started. We've just seen how a language can be less about communication and more about a scientific map of sound itself. And you have to ask yourself, if a language can be this perfectly engineered, what does that tell us about the incredible minds who put it all together? It really makes you think, doesn't it?